Okay, welcome to today's Q&A. I can see just okay, 3%. So let's give time for others to quickly join before we begin. Let's give time for others to quickly join. So while we're waiting for others to quickly join us, I would like to know this, that if you know you're here, just say hi, so I'll know those that are present. Okay, Joshua, nice to have you. All football, nice to have you here. So while we're waiting for others to join, we'll start by talking about the strategies. We'll start by talking about the strategies. Oh, Miracle, nice to have you here. So we'll start by talking about the strategies to actually ace this exam before we go into the past questions. Let's just use that to wait for others to quickly join us. So let's talk about the strategies. You know, every examination has its strategy. Every examination has a strategy for you to ace that exam. Even if you must have read very well and okay, you know what you're going to write. Every examination has a strategy. So what are the strategies for this council examination? Okay, over the years, I've noticed a lot of mistakes that students make. Let's start by the organization and time management. It's very, very important. Organization and time management is very, very important. Now, what do I mean? The exam is 3 hours. And within that 3 hours, you're expected to do the practicals. And you're also expected to report the practicals as well. And also sign the practicals, especially for microbiology and some other departments. They require you to sign the practical as you're performing them. So you see that there's a lot to do in that 3 hours. Now, how do you manage your time? I'll give you 2 strategies on time management. You pick whatever way that is the best work for you. Number 1, the students are many. You know that the students are many and there are limited materials and there are limited lecturers to attend to you to sign. So what do? Strategy 1 on time management, and I hope you're writing this down so you pick the one that will work for you. Strategy 1 is speed writing in 45 minutes to report all the lab. You report all the lab, but before you do that, you assess the some years back. She came into the hall and when I say she was too proactive, she went to the slides on her table and used continuum and was clearing all of them without realizing that histo slide is part of them and there is tissue that is impressed upon that slide. Now she used that continuum to clean off the sample, the tissue that was on that slide, and at the end of the day she was lost. So one thing you should do is observe your bench, observe your table. Okay, what's in front of me? What am I giving? Okay, there's a petri dish in front of me with organism growing on it. There's a slide with a tissue embedded into that slide now that I have to stain. Okay, is there ASR for hematology that I will have to stand, that will take a while? Is there anything I'll have to make a smear and allow to be drying in case I don't have hot air open to be drying for me? These are the things that should be going on in your mind even before they give you question paper or answer booklet. That's the point. So immediately you enter the exam hall, for you exam has begun, even if they don't start timing you. So immediately you enter the exam hall, assess what is in front of you and don't come late. Assess what is in front of you. Once you've assessed what is in front of you, say, okay, there's bacterial identification, there is ESR, okay, there is MP for me to make. So I have to make blood film to be drying. Okay, I have to make smell for gram staining to be drying as well. Okay, what else is there? Okay, is there stew, so that I have to stand my flotation method for the stew for 30 minutes to be standing while I'm writing. You see, these are the things that you have to factor in so that you don't get lost along the way. Now, in the middle of this strategies, if you have any issue, you can just say that, or you can just ask your questions. Now, what you do once you come into this thing I'm saying now are things they're going to use to pass this exam next week. This is not something you have been taught or any other. I'm telling you how to pass this exam now. Once you enter the exam hall, you've located your reg number and the area you're supposed to stay. Okay, what is in front of me? Okay, this. Okay, 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 okay. This is in front of me. Now, immediately you're given the question paper. The reason why I should wait for the question paper before you begin is to know if what you have in your head is exactly what the examiner or the person that is assessing you is looking out for. So immediately you see your question paper and exactly what you're expecting, you begin to stand whatever needs to be stood, like your ESR. If there's ESR, you stand it. If there is any other thing, you put it in place. If there's something to be dried, you put it to slide to be drying. Then you begin writing. So you speed write for 40 to 45 minutes. Now, once you're done writing, you begin the practical. Now, the idea of this, there are a lot of students, and you don't want to be in that mess of rush. So the idea is to finish your write-up quickly, and then begin the practical when everywhere is still quiet and free. So what you do is begin your practicals immediately. Once you have ground still and you focus and it's ready to view, the scientist or whoever is in charge is still very, very free to attend to you. Unlike when 50 people are calling one person. So you see that it gives you ample time to perform this test with the limited resources and microscopes that you're going to have on that day. So maybe you finish your writing in 45 minutes and already you use like 15 minutes to stand whatever needs to be stood, or to make your smear, to make your blood film, and then you start writing. So I believe that by the time you are done making your preparations and writing, is 1 hour is gone. So what is left is 2 hours. Now you're expected that you should use that 2 hours to finish the practical and also sign. So that's the first strategy on time management. There is another way I noticed someone doing it. Now, what did she do? She will write title, aim, principle, procedure. She will skip. She will give space and then go to result. She did that for all the tests. She just did that same thing for all the tests. She kept jumping and jumping and jumping. She wasn't writing much. Then she started the practical. Immediately she was done. That's when she came back to start filling those long procedures and everything. And at that time, everyone was still calm. Nobody had messed up the xylene. The stains in history were still good. The scientists were still cool-headed to attend to her, to sign everything she wanted. So you pick out of the two ways. So tell me in the comment section, which way do you think is best for you? Because either way is still beautiful. The aim is to do your practicals when others are still writing, when others are busy doing something else. So that you are using the judicial stain when it's still in its right state. It's not already contaminated. The normal cell line is still okay. It's not contaminated. Everything is still available to you. That there are still people to attend to you. You are not in rush hour. So that's the idea of time management. So that's about time management. If you have any comments or any question on time management, you can let me know. Now, I do a small, will I call it interview sessions with the different scientists. So for the purpose of today's Q&A, we're talking about, we'll be doing past questions and strategies for medical microbiology and hematology. Tomorrow we'll do for chemical pathology and histopathology. So I took the pen to go. So aside, I went to hematology and I was told something. The students don't write results. Wow. So I was curious and I asked, what does she mean that the students don't write results? So she gave me an in packed cell volume. So most students, because they're not confident of themselves and they perform this test, they want to wait for others to do the packed cell volume to compare their results with others. Okay, let's assume they did the packed cell volume and they got something like 30, and they're waiting for others to check other people's results to see what they actually got. And at the end of the day, you know how the exam progresses. It's very big, gets big. At some point, they will stop you to this person. So along the line, most of the time, students forget to report the PCV they already did. They did it, but because they're not confident, they were waiting to compare their results. They ended up not writing results. So it's a big issue, and I think it's something you should arm yourself with and know. Okay, someone is saying, "Ma, please, how many questions highest can be expected from each laboratory?" Because I'm trying and practicing to fill 3 topics each from each 4 labs under 1 hour, but it's safe to say that I didn't. Okay, each lab will ask you nothing more than 2 questions, or two serious questions and 1 minor question. So that's how it's with this 400 level. Each lab will ask you two questions. If they want to ask more than 2, the third one is going to be very minor, or they give you what do I mean, these little follow-up questions. For instance, you do ABA, they'll ask you a follow-up question, but the particle itself is usually 2 particles for each lab. So let's continue. So she told me about the PCV, and I was like, okay, that means they should always be confident of themselves. And even if you're not confident of yourself, report the way you did first. Report it. So that space, that score will not be lost. So that's for the first thing she told me. And then I noticed something over the years as well. Students cry, especially girls, because their items get stolen. So what do you do? By now, see what you do. Go and get a masset. Get a masset. Remove those massets you know. Remove the items inside the masset. Now, what you're going to use that masset for? You're going to keep your capillary tube inside that masset. You're going to keep your stain slides inside that masset. I mean, like your stain slides before you put emulsion oil. You're also going to keep in that masset your histo slides that you've already made. Please don't make that mistake. People steal items, and your bench is usually marked. So because you don't want your items to be stolen before you are assessed, please, you store them in that masset. And once you store them in that masset is always with you. And if in the event of you leaving your seat to go and spin your PCV or do something, please put your answer booklet always in your pocket. Please don't ever make that mistake. Don't ever forget. Put your answer booklet always in your pocket. I see people making a mistake of leaving on their bench, and over the years you find out that when the person comes out, someone else is using your booklet now to copy, and then the lecturer will think that you are actually supporting malpractice, and you'll be penalized for it even though you didn't know anything about it. Or sometimes you may be placed in a bench close to the stealing bench, and when you come back, students that messed up your booklet with stains, and you start crying. So to avoid all of that, always put your booklet in your pocket. And another thing, write your reg number on each page, every single page of your answer booklet. Write your reg number on every single page. So that's about how to go about your practicals. Now, the next thing she said was they ignore sub questions. This is hematology. She said people ignore sub-up questions. For instance, ask you to perform ABA for a couple of blood samples, and then there's a follow-up question like, okay, who can donate blood to the this the recipient B now? And then you don't answer it, probably because you got caught up, you thought it was just practical, you forgot that there are other minor questions. And like she said that these sub questions even carry more marks. That if you look at the question part, you see that they even carry 17.5, and students forget to answer them. Simple questions. So please don't get carried away or forget the sub questions. Always answer the sub questions. You are the boss on that day. Manage your stage very well. Don't allow anybody to distract you. So the next thing she said was protocol table is not the result. Wow. You know, in ABA, there is this protocol table you could have where you write the sample, the anti-A, anti-B, anti-AB, and anti-B, and then the blood group. Some people, because they wrote the column for blood group, they feel like, okay, there's no need to write the result. Now, your tutor is saying that protocol table is not the result. The result itself carries score, which you lose when you don't write it. So after the protocol table, ensure to write the result. And the result is not A positive, B positive. No, that's not how to write the result. Let's assume you carry out ABA for sample A, and the person's blood group is AB positive. What you're supposed to write is blood group AB resource D positive. You write it in full. So on the protocol table, you are deviated. Now, writing it as result, you have to write it full. You have to write it in full. Just as if you came for lab test, how you give result to your patient. That's how you have to write it now at the result level. Then the next thing she said, and yes, she said that the after the protocol table, there is a key that shows you key for plus sign for agglutination and negative sign for no agglutination during the result table. Then the next thing she said is that do protocol table for all the samples given. Now, some people are like garbage in, garbage out. You give them protocol table for all the different blood group, and then on the exam day you bring out just 2 blood types, but they say report all the blood types. Now you are only to write the protocol of the ones given. So if they give you only blood group A positive and blood group B negative, it is only those 2 that should be on your protocol table. You don't need to start writing all the others. It shows that you did not answer the question. You just garbaged out what they did in class. So this is exam now. You are going to take out the protocols for those ones given to you on the exam day. So you don't write everything they gave to you in class. So that's what she said for protocol table. Now the next thing, it's a tightening of ABA protocol table. Now some students don't know how to title their ABA protocol table. What does she mean? You know, this side of, I don't know if you see this very well, but let me try. You know, the protocol table is this way. You have your samples. You have samples there, and then here you have your anti-Sarah. You have, so what you have here is anti-A, have anti-B. Do you understand me? And then here you have anti-AB. And then here you have anti-B. So what she's saying is that some students do not write this anti-A. Some students do not write this. They don't write anti-A. What they do, they just write A, B, A, B, B. They don't write anti. Now, that anti means anti-Sarah. You can either write anti-Sarah A, anti-Sarah B, but just writing B, D is wrong. Is wrong. That is the column for anti-Sarah. So you should always write it. This is what we're talking about first. Now the next thing, she said that students forget ABO of patient and do only donors. Now what do you mean? I should give you a transfusion scenario where there is a donor that needs a recipe or three. Now, most times, some students, not all this time, according to what she said, only for the donors, forgetting to do blood group as well for the recipients. Now, when they are asked to assess your question very well, read the question and understand it before you start answering. Do not start writing because, okay, I don't have to do ABA. You can choose the question, and then at the end of the day, you're not answering the question. You're just do before you start answering it. The next thing she said was, some students don't know how to read PCV. Is plus or minus 2. So imagine you are getting, okay, the PCV is supposed to be 32 and getting 35, 36. You are wrong. So it's important you know how to use your microhematocrit reader. We're going to talk about it when we start answering the past questions. We'll answer it, we'll talk about it. So please, we will learn how to use the hematocrit reader today. We'll learn how to use it. Now the next thing is accurate pipetting. Accurate. Now I took out time for this one. Now I'm going to show you now. Now it's so fashioned that you may not be armed with the glass pipette that uses the pipette filler. You may not be armed with this that is graded in meals. So all you have to do is just go to the meals you want. You may be given the automatic micro pipette graded in microliters. So how do you use it? First of all, you have to find out what micro pipette are you given. Is it the one that is in 1,000 or the one that is in, oh my goodness, this one I have here is not working. Oh, I will have to do this tomorrow when we're talking about chemical pathology. I'll get a fresh one. This one is not working. I'm so sorry about that. This one is not working. So I'm still going to talk about it, whether it's working or not working. I will still talk about it. Now this big one is graded, the limit is 1,000 microliter. So let's assume, we're talking about hematology now. Let's assume we want to perform hemoglobin estimation, and you are expected to pick 4 ml of Draken solution. Now, because this automatic pipette is in microliter, you are going to pick this 4 times. You put it at 1,000 and you pick 4 times. You're going to pick this 4 times. You're going to pick this 4 times because 1,000 microliter is equal to 1 ml. 1,000 microliter is equal to 1 ml. Please, what you do, don't miss tomorrow's class. Tomorrow is the day of calculations in chemical pathology, and I'm going to simplify it as a primary school standard. So please do not miss tomorrow's class. We're going to do the calculation of conversions. 1,000 microliter is equal to 1 ml. So if you are giving this that day, for your HB. You pick your DraftKings 4 times into each of the test tube. Do you understand that? So that's about how to use this in for HB. But for this, all you have to do is to fill up to the 4 mark, which is 4 mils. That's all you have to do for your glass pipette. You see, this one is easier, but you may not get this that day because of the number, the quantity that is available. That's why you have to learn all the materials that we have. Now, she spoke about accurate pipetting. Accurate pipetting. Accurate pipetting. We're going to handle that. We're going to handle that. Now, although our pipette is not I think it's 40. I was given a 41 yesterday. I'm so sorry for that, but we're still going to learn. Now, if you look at this pipette very well, let's assume our pipette is already 1000 microliter. Use this to turn to 1000 microliter. Now you want to pick. If you want to pick, you put your hand here, and then you put your hand here, and then you press. You see that you are still seeing that red, you are still seeing the red band, right? That's where you should stop. Don't go further. Don't go further. This is how your hand should be when you want to pipette. So you, like this, you go into the solution you want to pick, and then you release your hand. That's the only way you do it to avoid picking air bubbles. But if you go all the way, you find out that you are going to pick more than the required volume. So that's for the automatic pipette. Now, the next thing she said was getting wrong absorbance from people. Like I said earlier, you have to trust yourself. You have to believe in yourself and know that you are good. So do not copy absorbance from other people. Do not think that, oh, I'm not good enough, let me wait to get other people's absorbance. And the next thing she said was mixing well after dilution. That's for your HB now. You want to perform your HB. You mix it very well. You mix it very well before you use your absorbance. Now it says guard your materials. We've already said that, and guard your booklet. Now that's for hematology. Now for microbiology, over the years, I noticed that students do not do the practicals. They just report and report and report and report, forgetting that the score is actually embedded in the signed results. What you may get basically for writing long grammars is just 1. So always ensure that you do the practical. Most times we come back and see our slides unused, plates untouched, and empty undone. So please ensure you do the practicals. It's very, very important. It's called a practical exam for a purpose. So do not leave your materials unused. Do not leave your materials unused. Several times I've seen where they are laughing while marking. So many will have HB results, but the DraftKings they are giving, they are still the same way they gave them. They didn't use it, but they have HB results. But they're not going that you copy. So you see how you give yourself out. So ensure you do this practical. Have the results. Have the results. So that's for that. So now we're going to start. I got several, although some people did not send some past questions, but others still did send some past questions. So we begin with hematology. Let's see the first question we have here. The question says, I want to believe you also have the past question because I got these questions from you guys. So I want to believe that you have these questions. Now, the first hematology question here says, blood sample Y is from a 32-year-old pregnant woman presenting with labor at O&G ward of Madonna University Teaching Hospital, Ilili. Question A says, determine the hemoglobin level of sample Y. Determine the hemoglobin level of sample Y. Determine the hemoglobin level of sample Y. Now, that question needs you to perform your HB. That is what that question needs you to perform. That question needs you to perform your HB. Now, I don't know if there's anybody here that does not know how to do the hemoglobin estimation, because that's what that question needs you to do. That's why we've been saying all these things with the preamble we said before we started answering these past questions. Because the most important thing now in this question is, do you know how to pipette? We're still going to repeat that to tell you how important pipetting is. I'm going to get a new automatic pipette and show you again how to pipette correctly, how to pipette right. Now, to answer this question, you say title, hemoglobin estimation. What is the aim of carrying out this test? Is to determine the hemoglobin level of the sample labeled what? Of the sample labeled Y. Please, as we're going, I will need you to be answering these questions too in the comment section. I need someone to tell me what is the method. What's the method? So you should tell me the materials we need. And what is the principle? What do you think? Let this class be interactive. Even though I still go ahead to answer. If you know the answer you give us. If you know that you have any question along the way, please do ask. Don't wait till the end. So the aim is to determine the hemoglobin concentration in the sample labeled Y. I know normally you're taught to write to screen and confirm for anemia, but now the aim will be as regarding that sample you're giving for the examination. Now, okay, someone said the method is Samet hemoglobin method. Correct. Now, the materials, as I learned, they said you should be writing everything they gave to you. So, what we need is pasture pipette, the diluting fluid, which is the Drapkin solution. Also, we need, depending on, I think what we have is the spectrophotometer, and then your test tubes. So now, what is the principle? What's the principle of hemoglobin estimation? What's the principle of hemoglobin estimation? Now, the principle states that when whole blood is mixed with 4 ml of Drapkin solution, there will be lysis and the hemoglobin will be exposed. The aim of the Drapkin now is to lyse the red cell, to release the hemoglobin so we can know its concentration. So the hemoglobin will be released. Now this hemoglobin is converted to net hemoglobin by what? Potassium cyanide. Now this net hemoglobin that is produced will be further converted to Samet hemoglobin by what? Potassium cyanide. By the action of potassium cyanide. Now, the color intensity is directly proportional to the concentration of the hemoglobin in that given sample. So that is it. And I will read the absorbance using what? 540 nanometer. So that's the principle for you. And it's measured in gram per dl. Yes, there's another thing that was said. Some people write the correct answer without the SI unit. Oh my goodness, that's a big mistake. Just like you do your HB now, you do not write the unit gram per dl. You just wrote 11. 11 what? 11 can be anything. So the SI unit is as important as doing the test. So please do not make that mistake. Do not look it for any reason. You do PCV, which percent at the end. Do not make that mistake. It's very, very grave. The next thing now is the procedure. The procedure. So you get 3 test tubes. One is your test. The second is your standard. And the third one is your what? Your blank. Now to the 4th test tube now, you put 4 ml of Drapkin solution. We said earlier, if you are giving this one, you pick in 1 test tube, you pick this 4 times. That is, you take your automatic pipette now to 1000 microliter, and then you pick that Drapkin into test tube 1 4 times. But if you are giving this, all you have to do is just use your filler to take it to 4 and then dispense 1. This is easier, but is that what you'll be giving that day? We don't know. So learn both. So this one is more in number, so you may be giving this. So what do? You pick Drapkins from this. You pick Drapkins 4 times into the first test tube. That's 4 ml. Like I said earlier, 1000 microliter is equal to 1 ml. So if you pick only 1, you have picked 1 ml. You pick again 2 ml. You pick the 3rd time 3 ml. You pick the 4th time 4 ml, test tube 1. Do the same thing for test tube 2, the same thing for test tube 3. Now you go again, you go to your sample that you're giving, you mix the sample very well. Remember that when a sample is left standing for long, it separates. And you know that before it will come from your CBT, the sample must have separated because it's standing for long. So you have to mix very well. Don't be in a hurry. Don't let it to distract you because that will affect your results. So you mix very well. You mix very well. Once you mix very well, then you pick for you pick 0.02 mils for your test. You pick 0.02 mil. Now some people are wondering, how do we convert that? How do we convert that? Now let's see this is, you only know that 1000 microliter is equal to 1 mil. Now, the protocol table says that we pick 0.02 mils. Now, we need 0.02 mils. So, how many quantity in microliter is that? We don't know. So, we cross multiply. And then we make this question mark now the sub formula. So, what do? The question mark will come here, and then you cross. So 1000 microliter times 0.02 mils all over what? 1. Someone should calculate this for me. If you multiply 1000 by 0.02 mils, give us the answer. There is mils here. So these mils will cancel these mils. So what is the answer? Someone in the comment section, please give us the answer. What's the answer? 1000 liter times 0.02 mils. What is the answer? 20 microliter. 20 microliter. Don't forget that the mils here cancel the mils here. So the mils, this milliliter SI unit now is off. Remaining the microliter which we are trying to get. So 0.02 mils. 0.02 mils is equal to 20 microliter. So you use the small pipette. You use the small automatic pipette, the one that is smaller than one now. That one is from 0 to 100. The one you use. You use that one now to get microliter and then dispense it into your test tube labeled test. You dispense it into your test tube labeled what? Test. Now, to the test tube labeled standard, you dispense 0.02 mils, which is 20 microliter, into the test tube labeled what? Standard. You understand the point now? So that's basically what you do. Some people will tell you to blank with water. I don't know. You try to blank with water or you leave it like that. Now, to get the absorbance, now the formula says absorbance of test over absorbance of standard times the concentration of the standard. So absorbance of test all over absorbance of standard times the concentration of the standard. Now remember, the concentration of the standard is always known. So the examiner is meant to give you at all times the concentration of the standard. So you should not look for that. It's always the question. It's always given. They'll tell you the concentration of the standard is 14 point this or this point this. So now let's do that. So we said absorbance of test over absorbance of standard times the concentration of the standard. Now, what is given in this question? Let's go back to the question we are trying to answer. Let's go back to the question we are trying to answer. Now, the question says, determine the hemoglobin level of sample Y. Now, the second line says, sample Z is hemoglobin standard. You see the reason why you should look at your question very well. There are some situations where somebody has just up hard, ma, I don't have standard. I don't. What is looking at it there? Just that it is encrypted into one of these alphabets that you are not aware of because you did not read your question. So now they are telling us now that our standard, that sample Z, is the hemoglobin standard. Sample Z. So you look for the test, the bottle labeled Z. You know, okay, that's your standard. They're going to pick 20 microliter from. Now they're telling you that the concentration of that standard is 14.7. 14.7. 14.7. So you know that's what we are going to multiply with. So whatever the absorbance of test that you got, you divide it by the absorbance of the standard, because now when you go to the spec, you are going to use the absorbance. You blank first, you use the absorbance of your standard, and then you use the absorbance of your test. So you have two absorbance. So you divide the absorbance of the test over the absorbance of the standard, then you multiply with the concentration that is given here, 14.7 gram per dl. Now whatever answer you get, please and please write it in gram per dl. Do not forget that. Do not forget the SI unit. Now, what is the dilution factor? The dilution factor usually is 1:201. I know you're wondering, how do they get to that point? When we are learning tomorrow, chemical pathology, we'll talk about calculations and dilutions and all of that. But let's just mention that. Now, in the dilution factor, when you want to carry out dilution factor, it's a very simple thing, because a sub question may be there that requires you to say, okay, what is the dilution factor? Now, the dilution factor is the summation of the solute and the solvent. Now, usually, if they tell you, okay, dilution factor is 1 in 20, you already know that the solute there is 1. The solvent should be 19. The number at the right hand side of the ratio is always the summation of the solute and the solvent. So if they say 1 in 20, you know that it's 1 ml of the solute in 19 mils now of the solvent. But now, how do we calculate this? For instance, now 0.02 mils of blood plus 4 mils of drapkins. So how is it going to look like? It's going to be 0.02 ratio 4.02. That's you've added this the blood now, which is the solute. You've added it to the solvent, which is the drapkins. That's why it's now points. This is supposed to be point 4.02. Now what do? You say 0.02 plus 4.02. So what should add this up for us? Sorry, plus 4. What you do is to add the solute plus the solvent. This is the ratio. What you do is to add the solute plus the solvent. If you add this to this, you are going to get this. If you add this 0.02 plus 4, you're going to get this. So you're going to get 4.02. So when you get 4.02 now, what you do, you divide the we divide the summation over the solute. So the dilution factor is equal to, let's just give it a title now, summation of solute or solvent all over solute. So this is basically the formula for dilution factor. So what is the solution of our solute? The solution of our solute plus our solvent is 4.02. So you say 4.02 over what? 0.02, which is the volume of our solute over 0.02. So what should give us the answer? 4.02 divided by 0.02. What is the answer? Divide 4.02 divided by 0.02. That's where we are. So what's the answer? It's 201. So that's the dilution factor. So you can say, sometimes if they ask you, so what is the dilution factor? Let's assume they ask you, for instance, what is the dilution factor? You will now say 1:201. I'm teaching you how to get that 201 now. I'm teaching you how to get that 201. The different dilution factors, sometimes you can get 1:251 or 501, but this regard now, our dilution factor is 1:201. I don't know if you are with me. If you are with me, say I am with you. So you see that we are done with hemoglobin estimation now. If you are with me, say I am with you. If you are with me, say I am with you. Okay, I am with you. Thank you, Chisom. Okay. So what's the next thing now? We are answering this question. We are answering is dated, in case you want to follow up, is dated 5th of October 2023. That's the question we are answering. So let's go back to the next one. We are done with part A. We cannot complete it. We cannot complete the process. We cannot complete it because we don't know the absorbance. We don't know. So when we stopped at the calculation, we already explained the procedure. Now, after you mix everything, you allow them to stand for 10 minutes. I forgot to mention that. You allow them to stand for 10 minutes. That's the test tube now. You are allowed to incubate at room temperature for 10 minutes before you take it over to read the absorbance. So that's that for, you should know the reference ranges now, but I'll still mention it. For male, the hemoglobin concentration for male, an adult male, is 13.5 to 18.0 gram per dl. Then for female, it's 11.5 to 16.5 gram per dl. For infants, 13.5 to 19.6 gram per dl. And for children from 3 months, is 9.5 to 12.5 gram per dl. Now, what's the clinical significance of carrying out hemoglobin estimation? It's a confirmation of anemia. You know, for people that have that anemic, that's probably the person has a sickle cell anemia, or the person's red blood cell is sickled. That means there's constant destruction of the red blood cell. That means the number of red blood cells that will be carrying hemoglobin to different parts of the body will be less. So those kind of people, their HB results will be low. So we use it to confirm. So we use PCV to actually screen. Why we use HB now to confirm? Because it's not specific using, yes. Thank you, Victoria. Victory rather. It's a confirmatory test for anemia and polycythemia. Because now we are going to the hemoglobin level now. We're not just doing at the red blood cell level, seeing how many of them are packed. or the level at which they are packed. You understand? So that's why it's a confirmatory test, because the hemoglobin is present in your cell and is needed for transport. So you see why it's very, very important. So that's the clinical significance of this test. Now, what kind of precautions can you give? You should not give so much. Just give maximum 2 and you move on to the next. Okay. Chisholm is saying 13.0 to 18.0. Is that still okay? Yes, it's still okay. 12.0 to 15.0. Yes, yes, yes. It's okay. It's still okay. Yes, yes, yes. You are still within range. You know, different laboratory with their reference range. So it's still within the range I gave. It's still the same thing. It's okay. It's okay. So Chisom, that one you give now is okay. It's correct. Now the precaution that you can give, you should ensure that this thing now has to do with the passage of light to check the concentration of a particular substance inside that has been produced, which is the cyanide hemoglobin now. So imagine your test is dirty. So it's going to affect the results. So you ensure that your test tube, they are clean and clear test tube. That's what you need. So you write as a precaution, I ensured that my test tube was very clean and clear. And you also ensure that you pipetted very well. I ensure that the proper amount of reagents and sample were pipetted into the test tube. So these 2 precautions, they are okay. They are okay. So move on to the next question now. The next question here says the B part. What do you see? Now, each lab has one they tell you question 1, but that question 1, the sub is the second particle. Do you understand? So while you will see 5 questions, the 5th one being spot, but each question now is pregnant with 2 particles. So now let's go to the second baby now in this question. The part B says determine the ABO and resolve D blood groups of sample P and donor samples K, L, and M. Three donors. Huh? So determine the ABO and resolve the blood group. Determine the ABO and resolve the blood groups of sample P and donor samples K, L, and M. So there is a recipient. The recipient is known as sample P, while K, L, and M are the donors. I'm sorry for that. Sorry for that. My mic went off. Hope you can hear me now.
Okay, thank you, thank you, thank you. So the title, what we're doing now, I don't know where you stopped to hear me, but I'm saying that we want to answer the B part now. So we are doing blood group now for 4 persons, 1 recipient, 3 donors. 1 recipient, 3 donors. Do not forget, you are doing ABO for sample P, K, L, and M. 4 ABO. Now, the title is ABO and resource blood grouping. What's the aim? What's the aim? If you know the aim, you tell us. And someone should give us the method. Another person the principle. Let's make this interactive. What's the aim? What's the aim of ABO and resource blood grouping? Okay, while the answers are still coming, we'll go ahead. So the aim is to determine the ABO and resource blood grouping of samples P, K, L, and M. That's the aim, because it's an exam condition. That's not your normal lab posting. So the aim should be to determine the ABO and resource blood grouping of the samples given in bracket P, K, L, and M. Thank you, Chisom. Now the method. Thank you, Emedium. The method is tile method. Tile method. You are usually given a tile. Usually given a tile. You're usually given a tile. Yes. And I think in the last exam, you were expected to come with your mobile lab. Yes. Students came in with their mobile lab. Yes. They came in with their mobile lab. And I think the mobile lab contains the tile as well, just in case you're not given. Just in case you're not given. Now, the materials provided are tile, antisera, cotton wool, pasture pipette, and a blood sample. Now, Chisom said the principle is based on antigen-antibody reaction to produce visible agglutination. Now, there is something missing in the principle, Chisom. There is a word missing there, and the word is corresponding. It's very important. That word is key. That word is key. Thank you, Anastasia. That word is key. You are missing the key word there. Corresponding. Corresponding is the key word there. Corresponding is the key word. You shouldn't miss it. Corresponding. So it's based on corresponding antigen antibody reaction giving rise to visible agglutination. So if you just say antigen antibody reaction, the person you may not understand it. But when you say corresponding, let's use this physics theory now of like poles attracting. Sorry, of unlike poles attracting. In my brain, I do it the other way around. So in ABO now, like poles attract. So if I am antigen A, I would agglutinate antibody B. And if I am, for instance, antigen B, I am going to agglutinate antibody B. That is corresponding antigen antibody. Corresponding, they must be the same. Or if you don't use the word correspond, you can't remember it, similar is another word. Similar antigen antibody. Similar antigen antibody. So what Lance Turner told us about ABO is this. God created us in such a fashion that if you have antigen A, you cannot have antibody B in the same space. So if you have antigen A, what you're going to have is antibody B. If you have the similar antigen antibody, there will be agglutination or transcription reaction. Maybe they gave it the same antibody. It's going to cause agglutination. So similar antigen and antibody cannot be found in the same place. I know a lot of people are having issue reading ABO. That's why I'm spending time here. And we're also going to spend time in the key. We're going to spend a lot of time, a whole lot of time in the key. I don't know how clear my board is to you. If my board is clear, can you say something in the comment section? Let's know if I can continue with the board or look for another means. Because I want to use the board now. I want to know, is the board clear to you? Our makeshift board. Can you see it? If you can, you let me know. So I will start teaching the protocol table now. Let's remove these ones. So we are done with HB. So let's create space for ABO now. I don't know if this board is clear to you. Can you see it? Okay, you said the board is not clear. Okay. Okay, the board is not clear. Okay. Let's have a makeshift board now. Since our board is not clear. Okay. So I'm going to use, I don't know. Oh, the board is upside down from your view. Oh my goodness. Let me see if this will work. Please, can you give me 1 minute? Let me get my pen. What I have here is a marker. So just give me 1 minute and I'll be back, please. All right. Sorry for that break in transmission. I didn't come with my pen. Now you see the board is not clear, so I have to change it. So now we're going to use, I'm going to use my notes here, and I'm going to change the screen so you can see what we're doing. Okay, so let me reverse my screen. Let me see if I can reverse my screen and clear my table. Because this is very important. I'm taking my time to do this. It's very, very important to get it. So many people don't know how to read their age. So let's get this right. Okay. So now, I have a manual here that I'm going to use. I think I've already made. Now, I hope this is clear. I don't see how I can stand this. Just give me a moment. I want to stand this for you to see. Okay. All right. Hope you can see this now. If you can see this, say I can see this. Say I can see this. If you can see this. All right, I can see this. So now, here, anti-A. Here, anti-B. And here, anti-AB. Or you can say anti-sera. Can call it in full. Anti-sera D. And then this is the blood group. Now, this side is a sample. This is the sample. Now, I know that what we're asked to do was blood group for sample P, K, L, but I want to do all the ABO, the possible ABO you can get, just in case for those that don't know how to read the protocol table. Now, this sample is what you should write on the exam. But the normal protocol table you have, what is written here? What is written here? This blood group is what is written here. So that is what I'm going to write here now. Just know this sample for exam. But for the purpose of this class now, what will be here is blood group. So we know different blood group. We have A positive, A negative, B positive, B negative. We have AB positive, and then we have AB negative, and then we have O positive, and then we have O negative. So now, what I'm trying to explain is that if someone has blood group A and has the resource factor. Now, resource is a type of blood grouping system. While the ABO is another type of blood grouping system, but the two of them are most important. So that is why we merge two of them together, ABO resource blood grouping system. So now, what you're seeing here is a combination of two blood grouping system. So, like we said earlier, similar antigen plus antibody will result in agglutination. So similar antigen antibody will result in agglutination. And don't forget, what we are putting here, like I said earlier, in your exam now are the sample. So what we are putting here now is the blood. What is here is the blood sample. What is here is the antisera. Now, what does the antisera contain? The antisera contains the antibody produced in factories and industry. It contains the antibody. And know that antigens are located on the surfaces of red cells. So antigens are located on the surfaces of red cells, but antibodies are located where? Where are antibodies located? If you know, you tell us in the comment section. Antibodies are located in the plasma. Antibodies are located in the plasma. Antibodies are located in the plasma. So once you know this fact now, and like I said earlier, I'm going to flip to the next page to do something. Now, remember, note these points. I hope you are taking them down. Blood group A has antigen A plus antibody B. Blood group this blood group, let me write it in full. So blood group B has antigen B plus antibody A. So the name of the blood group is always the antigen. Just know that. So if they say blood group A, you know that okay, it came from the name of what is contained in the antigen that is carrying. So blood group A will have antigen A, antibody B. Blood group B will have antigen B, antibody A. Now, blood group AB will have antigen A plus antigen B. No antibody. So blood group AB has antigen A and antigen B, no antibody. Now, blood group O has antibody A plus antibody B, no antigen. I need you to know this. This is a fact you have to know. Once you know this fact, doing ABO is as easy as anything. So know this fact. If you need to be singing it as a song, please do. Blood group A has antigen A, antibody B. Blood group B has antigen B, antibody A. While blood group AB has antigen A and antigen B, no antibody. While blood group O has antibody A and antibody B, no antigen. Okay, someone is saying, Ma, please, why does blood group O have no antigen? That is because that's how God made it. So this one is factory setting. It's not determined by any scientist. It's just like that. It's just like someone that does not have something, you don't have it. It's not like it's because they did one mathematics. They just discovered that the antigen present in other people, those that are called blood group O, they don't have it. They don't have it. They don't have it. That's why they are called blood group O. They don't have it. Just take O for Okpo. They don't have it. The second blood grouping system, like I said, this one is ABO. The second one is the rhesus, gotten from the name of the monkey, rhesus. Now, it's very straightforward. It's either you have the rhesus antigen or you don't have the rhesus antigen. So it's either you have it or you don't have it. Now, those that have it, that's why you see plus. Those that don't have it, you see minus sign, or which this plus sign is called positive. The negative sign is called negative. So it's either you have it or you don't have it. So when you combine the ABO and resource together, that gives you something like A resource D. So the D there is telling you the name of the antigen. The name of resource antigen is D. It's called the antigen D. So that's why I say anti-D. Anti now is the antibody against the resource antigen D now. Do you understand it now? So now, know this fact, know this. So blood group A will always have antigen A, antibody B. You see, opposing antigen antibody, if they are similar, clotting or agglutination will occur. Blood group B has antigen B, antibody A. Blood group B has antigen A and B, no antibody, while O has antibody A and B, no antigen. Now, knowing this fact, once you have known this fact, now let's go back to our protocol table. Remember that I said that the antisera contains the antibody. The antisera contains the antibody. The antisera contains the antibody. That's the antisera is the antibody. While the patient sample now, the patient's red blood cell now contains the antigen. Like I said, the antigen is located on the surfaces of the red cells, while the antibody is in the plasma, which is not what we're looking at. What we are doing now is serum grouping. So the method of this test is serum grouping. So what we are doing even is to check the antisera, react the antisera against the patient sample now. So let's do that. Knowing that blood group A now has antigen A, antibody B. Now, if you react this blood with antisera A, will there be clumping? Will it be a plus sign or a negative sign? Will it be a plus sign or a negative sign? So you know that this has what is antigen A, and this is antibody A. Let me be calling it antibody now instead of antisera, so that you'll be getting it. This one now is carrying antigen A now, and this one is antibody A. Would there be clumping? Yes or no? Would there be clumping? I want to know if you guys are up. Would there be clumping? Would there be clumping? There would be clumping, Chisom. There would be clumping. Remember I said similar antigen antibody will agglutinate. Already I said blood group A has antigen A. So what is located here now in this thing now in this one here is antigen A. Now you're reacting it with antibody A, similar antigen antibody. That is the principle. Similar antigen antibody will cause agglutination. So there would be clumping. There would be clumping. So here will be a plus sign. There now will be a plus sign. So now, if you react this blood group A now with antisera or antibody B, would there be clumping? Would there be clumping in antisera B? No. Beautiful. So there would be no clumping here. Because we already said that similar antigen antibody will agglutinate. So now let's go on. The next one. If you react blood group A with antisera AB, will there be clumping here? Remember that antisera AB will have antibody A and antibody B. So will there be clumping here? Would there be clumping? Yes. Thank you, Victory. Thank you, Sylvia. There would be clumping. Why? Because similar antigen antibody. The blood group carries antigen A, and now there is antibody A here. There is antibody A here as well, together with antibody B. So there would be clumping in antisera AB. Now let's come to the resource factor now. Antisera D. Now, the blood group is saying A positive. Would there be clumping here? Anastasia, there will be clumping. Plus sign. Plus sign means presence of antigen D. So there will be clumping. There will be clumping. Thank you, Victory. Thank you, Sylvia. So there will be clumping. There will be clumping. So let's go over to A negative. The difference between A positive and A negative, the difference with A positive and A negative is just loss factor. So while every other thing is going to be similar, the resource factor is going to be different. That's the only thing. That's the only thing that is going to be different. So while here you write, let me tell you how you write it. This blood group now for your result. What you write is blood group A, RH, D, positive. So this is how you report it. Blood group A, resource D, positive. So for A negative now, thank you Chisom. Thank you, Chisom. For A negative, now the only difference will be in the anti-D. So we can quickly go and do positive, negative, positive. Then here will be what? Negative, because the person does not have the resource factor. Now let's go over to blood group B. Blood group B positive. Now remember we said similar antigen, antibody will agglutinate. And like we said over here, we said blood group B has antigen B and antibody A. Blood group B has antigen B, antibody A. Knowing that fact now, we know that the antigen is on the surface of this red cell. Now, we are reacting it with antiserum or antibody A now. Will there be clumping here? Is there going to be clumping here? Is there going to be clumping? Remember, similar antigen antibody will react. Now, there is no similar antigen antibody here. What we have is antigen B and antibody A. So there would be no clumping here. Now, let's come over to this now. It has antigen A. This is antibody. Sorry. This is antigen B. We are in blood group B now. This is antigen B, and this is antiserum antibody B. Would there be clumping here? Would there be clumping here? What do you think? Would there be clumping here? Of course, there would be clumping because, like we said, similar antigen antibody will agglutinate. Some people are still making mistake. Just know that on that sample they are giving to you now, that sample P, K, L, and M now, that sample, see that sample for the purpose of this exam, see the sample as the antigen. Out it, just see the sample now as your antigen, and then see the antigen you as your antibody. So while you are seeing the sample P as your antigen, see the antiserum given to you as antibody. So ask yourself now, if there's clumping there now if there is clumping in the antiserum antibody B now, then you will know that what this person carrying, why there's clumping, is because there's also similar antigen. So if you see the one of antiserum B clumping, you know, oh, this person also have antigen B. That's why there should be clumping. You see, it's a very straightforward. Okay, they are answering old questions. Oh, I see. Oh, I see. Oh, I see. Oh, I see. Oh, so it's of no fault of yours. So move ahead. So now, blood group B now, having antigen B, will there be clumping in antisera AB? Of course there will, because it has both antibodies. So here there will be clumping. Now let's go over to antisera D. Now because of the plus sign here, there would be clumping because it has the resource factor D. So now for blood group A negative, what you write is A resource D negative. While for blood group B positive, what you write is B resource D positive. Remember, according to what your tutor requested for, this thing now is what you excavate and write as your result when we are done with the protocol table. So the next thing now, for blood group B negative, is blood group B positive. The only difference is in the resource factor. So we'll be quick about it to say negative, positive, positive, and here will be what? Negative, because it does not have the resource factor. So now what we're going to write here will be B resource D negative. You see how easy it is? Just follow our principle. On the in the sample is the sample, see the sample as your antigen. See the antisera as your antibody. So just see it that way and don't forget about every other thing they've taught you or anything that's confusing you. Now, sample P, see sample P as the antigen. See antisera A as antibody A. See it as the antibody now. Now, if there is clumping in antisera A now, which is antibody now, you now say, sample P is causing clumping. That means it also has antigen A for it to clot antibody A as well. So that is it. It's straightforward. You don't have to crack your head too much about it. So let's go over to AB. So AB positive. And remember what we said about AB. AB has antigen A and also have antigen B. Right? That's what we said. No antibody. So AB has antigen A and antigen B, no antibody. No antibody. It has both antigens. Now, if you react it with antibody A, would there be clumping? Obviously, there will be clumping because it has antigen A that will react antibody A. Okay, you're not seeing the last part of the column. Oh, the last part of the column is the blood group now. I'm saying it with my mouth, but because of the nature of this stand I'm using. Okay, let me see how I can adjust it for you. Okay. Okay. I hope it's better now. So you're seeing it now. So what we're saying is AB positive now. AB positive. AB positive. AB positive. AB positive has antigen A and also has antigen B. It has both antigen, no antibody. Now, if you react it with anti-sera or antibody A, will there be clumping? Would there be clumping? Of course, there's going to be clumping. There's going to be clumping. And why is there going to be clumping? There's going to be clumping because AB now has antigen A and also has antigen B. And you're reacting it against antibody A. So antigen A is reacting with antibody A. So there will be clumping. So you put a plus sign there. Now, we also react Is it going to react with anti-sera or antibody B? Of course, it's going to react. Why is it going to react? It's going to react because there is antigen B here, and you're reacting it with antibody B. Like I said, I'm calling antibody the anti-sera. It's the anti-sera I'm calling antibodies, so that you understand this thing. I'm teaching it in a way that you can easily get it for the purpose of this exam. I don't want to speak too much grammar here. I'm teaching for the purpose of this exam now. See the anti-sera as the antibody. See the sample as the antigen. Is the best way to do ABO. Now, because AB now has the antigen B together with antibody, antigen A. It has antigen A and B. If you react it with antibody B now, there will be clumping. Now, if you react it with antibody AB, remember that it has both antigens. So, of course, there is going to be clumping here. Now, there's a plus sign here showing that. Sorry about that. There is a plus sign here. There is a plus sign here showing that it has a resource factor. So, of course, it's going to react to the anti-D, which is the antibody D. It's going to react because there's a plus sign here. You understand it now? So whenever anti-D reacts during your exam, know that the resource factor is present. So it's a plus sign. So whenever you see a plus sign here, you know that you are going to have, you put a plus sign on top of the ABU. So now, sorry, I'm going to drop this now. I'll take it this way. Okay. So what we have now, our blood group, we're going to call it, our blood group is AB resource D positive. You see? Easy does it. So the next one now is AB negative. AB negative. AB negative. It's going to be the same thing with AB positive, only for the resource factor. So I'll draw a line here. So we'll just pick it same way, plus, plus, plus. AB negative has no resource factor. It does not have the resource antigen D. So it's not going to react here. So what you have is a negative sign here. So what would the blood group be? You say AB resource D negative. What you are putting in brackets on top is the D. See how I'm writing my own? You see this inverted comma above? It's for the D. Now you rule again. Let's do for O, so we can proceed. Now, like I said earlier, if you remember earlier explanation, what I said was blood group O has antibody A, antibody B, no antigen. It has antibody A, antibody B, no antigen. So because of that fact, there is no antigen here. Remember that we are reacting this antigen against these antibodies. Don't forget though, at this point, some people get confused, but I don't want you to get confused. Remember that we are reacting the antigen against the antibody. Remember, we are reacting the antigen against the antibody. Why are we saying that? Remember that the question says sample P is the recipient, K, L, and M are the donors. So for to know the donor, the right donor, or against donor's red cell. So this is the donor's red cell. So what we are concerned about for the donor is the antigen. For the donor now, what we are concerned if he has similar this thing now is the antibody. Now they are sorry, is the antigen. What we are concerned for the donor is the antibody. For the sorry, I'm making a mistake now. For the recipient is the antibody. For the donor, that's the person giving the blood, is the antigen. So now these ones here, now we are seeing this blood group here now as the donor now. We are seeing them as the donor. We are seeing them as the donor, the people that want to give somebody blood now. So what we are concerned about is, do they have the antigen? Do they have antigen? Because that's what we are reacting against. The reason we're looking at it that way is because the antibody in the serum now is not so much as to cause a problem. That's for the what do they call it now? For the donor. So now O now has antibody A and B, and you're reacting it against anti-serum or antibody A. Would there be clumping? No. If you react it with antibody B, would there be clumping? No, because it does not have any antigen to go into any reaction. It doesn't have any antigen. Remember, the principle states that it's antigen antibody that causes similar antigen and antibody that causes agglutination. Now, there is no similar, in fact, there is no antigen here. It does not have antigen. So there's nothing going into this reaction to cause any problem. Do you understand it for the ABO part now? So even here will be negative. It does not have, what it has is antibody. So antibody will meet antibody and cannot cause reaction. Antibody plus antibody cannot cause any problem. So now the only issue now is the plus sign here for anti-D. It has a resource factor. So here it's going to be positive. So what you have is O resource D. Okay. O resource D positive. Now let's go over to O negative now. It's going to be similar, but for the resource factor. So negative, negative, negative. No resource factor. So here it's going to be negative. So we have O resource D negative. Now, we are going this route because we don't have the live sample, or we don't have a blood sample here now to term P, K, L, and N. Teaching you everything just in case you see a certain one out of these ones that we're saying. So now what your tutor is saying, in exam condition, you're giving a protocol. This is a protocol table now. Do not give everything as you have seen here now. Do not give everything. Only report the protocol table for the samples given. Now, they gave you 4 samples. So you should have four blood groups here now. Not, what we have is 1, 2, 3, 4, 5, 6, 7, 8. What you expect to have is 4 blood group, not 8. Do not go and report this thing now as it is, or like they gave to you in class. Do not go and report everything. You report based on what they gave to you in the exam condition. I don't know if someone is understanding. If you have a confusion about this thing I just said, you can just ask your question now in the comment section. You only report protocol for the blood giving. You have 4 samples, so you should report only 4 protocol tables. You shouldn't report more than that. Now, if you look at this protocol table now, you see AB positive. You see AB positive. So you see why this AB positive is called universal recipient. It's called universal recipient. Why O negative is called universal donor. Universal donor. Universal donor. You see, it can get blood from anybody. AB positive, sorry. Yes, AB positive is the universal recipient and can get blood from any blood type. Why O negative is the universal donor and can give blood to any blood type. He said, please, can you give us an example of how the protocol table for sample P, K, L, and M should look like? Okay. But I hope you understand this general one we've given first. Before I move on to that one, I wanted to give the general one first before we give something that will look like that particular one. I hope you understand this general one first of all. Answer yes or no, so I will know if you understand this one before I'll move on to answer the question directly. Because you need to understand the entire thing first of all before we go over to answer the question in particular. Okay, you do. Now, let's draw a protocol table. Let's draw a protocol table now to answer this exam question now. So what you should have here is antisera A, antisera B, antisera AB, antisera D. And then here you have sample. And here you have blood group. So here you have sample P, K, L, M. Do you understand it now? So this is how it should look like. So let's assume I will just mark this anyhow. You will be telling me, okay, now you give me the comment section, you will tell me sample P, you tell me the blood group. So let me assume I mark. Okay, can you kindly answer the question? This is now alternative to the practical. So now let's assume I reacted my tile. Now I added, the procedure said onto a clean, grease-free tile, a drop. Now what you do is to put a drop of, see, most people make this mistake. Apply your antisera before applying the blood. Apply the antisera first before applying the blood sample so you don't contaminate the antisera. So you put a drop of antisera A drop of antisera B, antisera AB, and antisera D onto your clean grease free slide now, tile rather. And then you added a drop of sample P and reacted it and rocked for 2 minutes. What would this blood group be? I want to know, what would sample K, what's the blood group? Sample L, what's the blood group? Sample M, what's the blood group? I'm waiting. I'm waiting. Sample P is blood group AB resource D positive. AB resource D positive. That's beautiful. AB resource D positive. So what is sample K? Sample K is what? What's sample K? Chisom said sample K is blood group A resource D negative. Oh, that's so beautiful. Blood group A resource D negative. Okay. What sample L? Oh, Precious, thank you. You also got it. What sample L? What sample M? Okay. Sample L is blood group. He says sample. Chisom says sample L is blood group B resource D negative, resource D positive. Okay. Oh, thank you. Thank you. You guys are awesome. 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 This is beautiful. This is beautiful. So M is what? What is M? M is left now. So this is how your booklet in your exam will look like. Oh, on top you write protocol. Protocol. So what's left is M now. What is M? M is blood group O resource D negative. Oh, beautiful, 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 beautiful. Now, let's go over, there's a follow-up question. Now we've drawn the protocol table. So once we've drawn the protocol table now, your tutor says you write key. You write key. You draw this box. I hope you can see my box. You say positive, negative. You say agglutination. This, you say no agglutination. Then you come down and say result. Very important. Then you say sample P. You bring this thing now, you bring it down. Sample P, A, B, resource D, positive. Sample K, you say A, B, okay, A, resource D, negative. Sample L, B, sample L, B, resource D positive. And sample M, you say O resource D negative. So you see, this is how to write the result. So now you've written the result. Now let's answer the follow-up question. What's the follow-up question? The question now says, you say, now the B part, we have done it. The B part says, determine the ABO and the resource D blood groups of sample P and donor samples K, L, and M. We have done that. The C part now, which is a follow-up question, and according to your tutor, she says, you people always forget to answer the follow-up question. Some will do the ABO and say, oh, I'm done with Hemat. Let me go over to Chem part. No, you're not done. There is a C part. C says, recommend the most appropriate donor blood for possible cross-matching and transfusion. Recommend. So who is the best donor? Please comment. Tell us. Don't forget that P is the donor. Sorry, P is the recipient. P is the recipient, while these guys are donors. They are donors. So between K, L, and M, who are the suitable donors? Suitable donors. Suitable donors. Suitable donors. Wait in the comment section. Suitable donors. Miracle says sample M. You give it with reasons. You tell us your answer with reasons. Miracle says sample M is a suitable. Sample M is suitable donor. You give us your answer with reason. Don't just say sample M. What's your reason? Chisom says sample M is a suitable donor. What is your reason? Any other answer? Aside Miracle and Chisom? Is there any other answer? Is there any other answer? Okay, Chisom says because sample M is blood group O, and blood group O is universal donor. Okay, because it's universal donor. But what is the reason or the fact or the property has that made it broad universal donor? That is the reason why it's suitable. Not because we call it universal donor. Why do we call O negative universal donor? We call O negative universal donor because it has no antigen at all. So see, the principle in medicine is the less you expose your patient to antigens, foreign bodies, the better. So because O negative has no antigen at all, that's why it's best. But sample K, L, and M, don't forget, they are all suitable. They are all suitable from this analysis that we did. A is resource D negative. It can give to AB positive. B, sample K, L is AB resource D positive. It can also give to AB. Remember that AB resource D negative, positive is a universal recipient. Do you understand? So that's what Anastasia is saying here now. So he can receive blood from all of them. So even though O resource D negative is a universal donor, it doesn't outsmart the others. In fact, in blood donation, you give O resource D negative only in cases of emergency. It is seen as the golden blood. O resource D negative is the golden blood. Do you understand? So you don't give it out recklessly. We don't give it out recklessly. The answer to this question is all three of them. All three of them are suitable donors, although O resource D negative is the universal donor. That's how your answer should go. All of them. And why? Because the recipient is a universal recipient. AB positive. Do you understand me? Do you understand me? Do you understand me? Oh, Sugar, good afternoon. I hope you understand what we're trying to say here. Oh, I think you're just coming, so it's difficult for you to catch up with us, and we are trying to beat time and other factors. So, Sugar, I think when we upload this video immediately after the live session, you're going to have a prelude of what we have been trying to say. We have been doing blood grouping all along, and if you watch our previous table here, we drew a protocol table where we try to talk about agglutinations and those that are not going to agglutinate. Eh? Do you understand? Yes, you're just coming. Yes, yes. So that's why I'm giving you a recap. So because we gave different blood group, this is the general protocol table that you are given in class, but this is not how you report it in exam. So we had to do this and then show how to report in exam condition. So now we've shown how A should look like in a protocol table, how B should look like in a protocol table, how AB will look like, how O will also look like. And we said earlier that similar antigen and antibody will cause agglutination, and that's the principle of ABO blood grouping. That the antigen is located on the surfaces of the red cells, and that the antibody is located in the plasma. So our question says that sample P, and we also said that blood group A contains antigen A and antibody B. We also said blood group B contains antigen B, antibody A. Blood group AB contains antigen A and antibody B. Sorry, blood group AB contains antigen A and antigen B with no antibody. While O contains antigen, no antigen. And then there is a and people answered, told me what the blood group would be if the protocol table on your tie and you see all four of them agglutinate. It is AB resource D positive. You rock on your tie and this react, this does not, this react, this does not. This is the answer. So that's what we just did. And you draw up your key, showing the sign for agglutination, the sign for no agglutination. And then you must also write your result, even though you've written blood group here. You come down and write your result and write sample P is this, sample K is this, and sample L is who the suitable donor will be. And because the recipient now is A D positive, which is a universal recipient, that means you can take blood from any of these donors. A resource D negative, B resource D positive, O resource D negative. You can get blood from any of them. So I hope you understand now. So at this point, I think we are done with the hematology question. And I am kind of running out of battery. So in the event of my phone going off, we'll resume this live class by 5 p.m. I hope that is okay with you guys. We'll run another 2 hours in the event of my phone going off. So now I'm going to switch over so we can talk about, like I said earlier, we're going to answer hematology questions and microbiology today. So now we've been able to do ABO. We've been able to do hemoglobin estimation. So we've done two. We have done two. We've done two. So now let's talk about the other part. So I'm going to switch over now. So I want to believe that all of you got what we're trying to explain. I want to believe you're able to understand the ABU. I know it's stressful. It's stressful. But I want to believe you're able to understand it. You're able to understand my explanation. Now, question 3 says, which is microbiology, it says the plate labeled O is an overnight urine culture of a 35-year-old woman presenting with itching and severe waist pain. With the materials provided, identify the organism in the plate as far as possible. Identify the organism growing on the plate as far as possible. So the plate labeled O, the plate labeled O is the overnight urine culture from a patient, a female patient presenting with itching and severe waist pain. With the materials provided, identify the organism growing on the plate as far as possible. Now, this is really easy because we already have previous videos on bacterial identification. So this one will be very fast. Now, if you're given a question like that, if you're given a question like that, like I said earlier when we started this class, I told you on the strategies on how to go about answering the question. I told you how to go about answering the question. And one thing I said was, look at the materials in front of you. Try to understand what's going on in front of you. One question you should ask, okay, what kind of plate am I giving? What kind of plate am I giving? Now, you should know the plate you're giving. What's happening in the plate? Now, let's assume you're giving a cleared agar, which is cysteine lactose electrolyte deficient agar. That's what you're giving. Okay. Even before the booklet goes round or they say start, you should be able to be doing the size. Okay, what is the size? And like I taught you, if because of our kind of board here, and I don't have a life ruler here, but in that video on colonial morphology, I really broke it down there. And I want to believe that you've all watched that video. Now, you know that your ruler is graded in centimeter, and the organism in question is measured in millimeter. Is measured in millimeter, and you know that 10 millimeter will make 1 centimeter. So for each box is 1 millimeter. So you measure the size of the organism. Just watch that video. You'll see how to measure the size of the organism. You check the shape. The organism can either be round or crenated. Sorry, can either be regular or irregular. When you say it's irregular, it doesn't have a definite shape. But once it's regular, the circumference of its circle is complete. That's the edge is entire, because it's the edge that gives the shape. So if the edge is entire, the shape is going to be round or regular. And then you check the color. Now, the color is dependent on the kind of media you're giving and what is going on there. If there is fermentation, if there is lactose fermentation going on, it's going to affect the color. That means if there is fermentation going on there and it's a cleared medium, that means it's going to be yellow. The color is going to be yellow. And please don't miss this thing. Each of those colonial features is half mark. And let's assume you're supposed to report 7 and you wrote only 5. You have lost 1 mark. So you see, each of those colonial features is half mark. So let's assume the consistency. You want to check the consistency. You use your applicator stick. You touch one of the colony and go up. You just touch the colony and go up like this. If the colony follows you as in phlegm, that's your catarrh. If it's slimy, you say, okay, the organism or the colony is mucoid. If it cuts, if it doesn't follow you, you say it is butyrus. So that's for the colonial, that's for the consistency. Now to check the elevation, you take the plate close to the same level with your eyes. You take the plate same level with your eyes and see if it has a shape like that of a hyperbole, a ball being thrown. If it looks like this, you say it is elevated. If it's just there flat on the plate, you say it is flat. So that's for the elevation. So you check the size, 1, the shape, the color, the consistency, the fermentation. What else? I think there are 7 of them. Size, the shape, the color, the edge, the consistency, the fermentation. I think I'm missing one, but it's usually 7. I must have mentioned one of them. Now, if the organism does not have a certain feature, please leave it. If the organism does not have a characteristic smell, as in odor, leave it. So you don't write odor and write nil. Vivian, don't write odor and write nil. Unless the organism has a characteristic smell, as in proteus, that has a rotten egg smell or a stockfish smell, then you can write it. But if it doesn't have a characteristic smell, don't write nil. Don't write it at all. If it doesn't have pigmentation, please leave it out. Don't write pigmentation nil. Anyone that it does not have, the organism they gave to you does not have, don't write it. Don't write it and write nil. Yes, elevation. Thank you. So now, the title. You want to report this number 3. Now you write title. Title is bacterial identification. That's the title. The title is going to be bacterial identification. What's the aim? What's the aim? So one should tell us the aim. It says this, the plate labeled O. So what is the aim? What's going to be the aim? What's going to be the aim? What's going to be the aim? I'm waiting. The plate is labeled O. So the aim is to identify the organism growing on the plate labeled O as far as possible. To identify the organism growing on the plate labeled O as far as possible. Now the next thing is to write what you are given. Please don't miss that, because you don't know if a score or a mark is attached to each of those points. Now you have to write what is given. Now let's assume what you're given. You say, what about for fermentation? Can we say non-fermenter? No. If the media you are giving does not contain a sugar that can be broken down, please leave it. Maybe you are giving clad, for instance, that contains lactose. Then you can write fermentation. But if you are giving a plate that does not contain any sugar that can be fermented, don't write non-fermenter. There's no need to write non-fermenter. So if the plate you are giving contains a sugar, do you understand me? So if the plate you are giving, for instance, is cleared now, is cleared, and then the organism is not fermenting lactose, there you can write no or nil there. That's where writing fermentation makes sense. But some people will write fermentation in a plate that maybe you're giving blood agar. There shouldn't be fermentation in blood agar, but there can be fermentation in cleared. So you see, writing fermentation in a plate that contains sugar makes more sense. Okay, sugar says to determine the bacterial identification in the given sample. No, the English is not correct. To identify as far as possible the organism growing on the plate labeled O is better. Sugar, hope you got the correction. So that's for, like I was saying, the plate that so you write giving, you put 2 dots, and then you tell us the plate you are giving. Write it in full. Do not write cleared agar. Do you understand? Or mark. Write it in full. 16 lactose electrolyte deficient. Agar. That's given. Then you write method 1, colonial morphology. Then you draw your table. Now that table will have colonial colonial characteristics and colonial features. Now when you list size, you write the size. Now there's a mistake students always make. And I'm so sorry to say that each time you make this mistake, you lose the score. Now I know that I give you the It's just like now, I tell you that, okay, my phone was stolen, for instance, and I told you my phone was stolen around girls' hostel gates. Eh? And the person that stole my phone is tall, he's dark, he's a guy. I gave you a range. I say, okay, it's between 6 feet or 6.5 feet tall. Do you understand me? So I gave you a range. Now, to catch the culprit has one height though. It doesn't have a range of heights. It has one height. Do you understand me? So now, the organism you're trying to incriminate that is causing this woman now itching and waist pain has one size, does not have a range of size. Now, the range there is because organisms of the same genus can have a range of size. Their colonial size can vary, but is within a boundary. So imagine someone coming on that size and saying, okay, size 2 to 3 mm in diameter. I should pick one. It's wrong. You're supposed to write one. It's either you will say size 2 mm or size 2.5 mm or size 2.8 mm or size 3 mm. But you saying 2 to 3, you are telling your examiner to pick one. You've not written the answer. Do you understand what I'm trying to say? So for size, don't write that thing we gave you in class. What you're supposed to write, you tell us the size you measured on that day. Because you're going to measure just pick one colony. Don't confuse yourself. Pick one colony and measure. Whatever you measure, that's the answer you should write. Don't write a range. Maybe you've crammed that, okay, staff has size 0.1 to 0.5 mm in diameter. No, you pick one. Is that you say 0.1, 0.2, 0.3, 0.4, 0.5. Now you go over to the shape. It's either regular or irregular in shape. Now, if you've watched the video on colonial morphology, you see how you know. You know the shape from the edge. If the edge is entire, then you know that the shape will be round because it's the circumference of the circle that tells you. It's the circumference of the circle that tells you what the shape will be. So if the edge is not complete, you know it's not regular. You say it's crenated. So you say it's irregular and then the edge is crenated. The edge won't be entire. So if the shape is round, the edge must be entire. So if the edge is entire, shape will be round. If the shape is irregular, that means the edge is what? Crenated. So now let's go back to the next one, color. Color. Some people make the mistake of saying, okay, because they gave you different color for different places, they tell you, okay, color. Somebody once said yellow in Cled, pink on McConkey, creamy on blood. That is wrong. You are garbaging out what they gave to you. You are not answering the question. The question is, what plate were you given? Now you're writing 3 different plates when you are giving one. So you see, you just la crammed and you're la pouring. You're not using what you've read to answer the question. Now, we only gave you color that you see for that organism on different plates. The question now is, what plates were you given? Is it a 16 lactose electrolyte deficient agar plate? If yes, is it fermenting lactose? If it is, and it's yellow in color, then you say color, yellow. You don't need to say yellow on Cled, pink on McConkey, creamy on blood. No, you don't need to say that. You just need to go straight to the point and tell us what the color is. And that's as simple as it should be. And for consistency, I've told you how to know the consistency using your applicator stick. Now, the next thing is elevation, which I've already said. What else? Odor. If you want to know if it has a characteristic smell, you don't need to put it to your nose. Just pass it through. Just pass it through like this. If it has a new slipper smell, say, okay, this is Pseudomonas. If it has a stockfish smell or a rotten egg smell, say, oh, this is Proteus. Don't write. Somebody wrote it has a funny smell or something like that. I don't know. Don't write what you're not giving. If it doesn't have a characteristic smell, leave it. Don't write odd or new. So that's for colonial features. Now, another mistake that people make in microbiology, they, after writing the colonial feature, they write gram reaction, gram positive cocci in clusters. Please do not write that. That's not colonial feature. I only used to give that thing to students to help them know the gram reaction of the different organisms together with the colonial feature. Doesn't mean that gram reaction is part of colonial feature. You will be scored down or low for doing that. So you see, after colonial feature, do not write gram reaction, gram positive cocci in clusters. Don't do that. You have not done the gram reaction. So how did you know that? Don't do it. Don't do it. And also, some people will write Staphylococcus aureus confirmed. Please don't do that. Do you hear me? Don't do that. Do not write Staphylococcus aureus confirmed. How did you confirm it from doing just colonial morphology? Different organisms can have one colonial feature. So how did you know that it's Staph aureus that is growing in the plate? So it's wrong. You cannot confirm an organism from just the colonial feature. So again, do not write Staph aureus confirmed. Do not write gram reaction, gram this. Don't write any of that. That's not what you're supposed to do. Now, once you've done the colonial morphology, the next thing you should write is title, gram staining. Aim. Please, someone should tell us, what is the aim of doing gram staining for this sample now, this plate labeled O? What will the aim be? What is the aim? What is the aim? So the aim usually is to differentiate gram positive, organisms or bacteria from gram negative organisms. So gram staining differentiates organisms into two basic categories, gram positive and gram negative. So that is the aim. Now remember, the precaution of this number 3 question comes at the end. So just follow me. I hope you're writing this thing down. I'm telling you how you're going to report this thing now. Yes, thank you, Sugar, to differentiate gram-positive organisms from gram-negative organisms. Now, after writing the aim, the next thing to write is the principle. Now, if you go to the video on gram staining, if you check the description box there, the principle as you should report it is there. The principle as you should report it is there. So you should just know that gram-positive organisms, they have a thick peptidoglycan layer, and they also have what they call teichoic acid. So because of these two things, they are able to retain the primary stain. So when you apply your crystal violet, it takes it in. Now, when you apply the Lugol's iodine, the Lugol's iodine is what? What's the Lugol's iodine called? Thank you, Vivian. Thank you for the aim. Thank you, Adesola. So what's the name of Lugol's iodine? What is it called? Lugol's iodine. It's called the mordant. The mordant. So when you apply the Lugol's iodine to this organism, after you must have you applied your what do you call it, your crystal violet for 60 seconds, and then you rinsed in water. One mistake, yes. From the previous week, those that have been coming to the lab to do gram staining, I forgot to mention, before I continue, I must say this. Now, I want you to know something. Know this thing. Learn it now and know. In fact, this thing is very, very important. If not be listening to what I've been saying since, listen to this one. One colony contains Thousands. One colony, just that one pump you see on the plate, contains thousands to millions of bacteria. So you don't need to pack it. Sometimes because you can't see this thing with your naked eye, you want to do it to the point where it's visible to your eyes. And you think, okay, now I've gotten it. No. Onto your clean grease-free slide, you apply a drop of normal saline, and then you take a very just touch the colony. You don't need to pack it. Just carry your applicator stick or your wire loop, any of them that is provided for you. Touch it. Just touch it small, just small, and then emulsify. That one you've taken is already thousands. But some people will take it and make a very thick smear. Now, when your smear is too thick, it becomes difficult for you to decolorize. And then an organism that is not supposed to be gram positive will become gram positive because you've made a too thick smear that you cannot decolorize properly. So you see, it's a problem. It's a problem. That organism you think you can't see, it is there. Just forget whether you can see it or not. Some people say, I can't see anything. No, it is there. Just make the smear and dry it. Once it's dried, you pass over flame. So like we're saying, we're talking about the principle now. The Lugos iodine, being the mordant now, creates a di-iodine bond. It's a loose bond anyway. It's not a covalent bond, but it's a loose bond between the crystal violet and so it enhances dye retention. It just enhances dye retention. So it helps the crystal violet to further bind to the peptidoglycan layer of the cell wall now. So the next thing is to rinse and then apply your decolorizer. Please, what is our decolorizer as regards gram staining? What is our decolorizer? Our decolorizer here is our acetone. Now we used acetone to decolorize briefly. You get your, assuming this is your slide with the smear now. You get your pipette containing the acetone, and once the acetone flushes through or flows through the smear and goes down, it's okay. Take it to water immediately. So your tap should be on a little, slow flowing tap water. You just rinse to stop the reaction. That's how to decolorize. You don't have to decolorize too much. If not, you over decolorize. So the principle states that you say, ma, please, after title gram staining, the next thing is aim to differentiate gram positive organisms from gram negative organisms. The next thing is materials. The materials is as provided. Gram staining does not have a method, so you leave method. Vivian, gram staining does not have a method, so you leave method out of it. So the principle states that, that's why I'm at the principle now. There is no method. So that material which is as provided. Yes, I'm talking about gram staining. Yes, there is no method. It's after title, aim. After the aim, the materials. After the materials is the principle. The principle states that is based on the ability of an organism to resist decolorization by acetone and retain the primary stain, which is crystal violet. Then you say that gram-positive organisms have a thick peptidoglycan layer plus teichoic acid that enables them to retain the primary stain and resist decolorization by acetone. Unlike gram-negative organisms that have a thin peptidoglycan layer and a lipid bilayer that makes them to lose the primary stain and take up the secondary stain. So they are not able to resist decolorization. So they stain red or pink, while gram-negative stain purple or violet. Should we? Okay, ma, we should not list the materials we're giving. Yes, just write as provided. As regard MCB, the reason is this: there are some things that you're going to request So it's based on your own request. So there's no need for you to write materials. Some person's materials will not be the same. So your ability to request the right thing now is you are getting score. Yes, do not list. When it comes to MCB, just write as provided. Other labs, please list it. But for MCB, just write as provided. Just write as provided. So go on. And before my phone goes off, we go on. After the principle, you state the procedure. Like I was already stating it before. Don't make your smear too thick. It's a problem to prevent you from decolorizing very well. Even if your eyes cannot see it, take the little as possible and emulsify. If the oven, now we're talking about exam condition now. I personally, for Hemat lab and microbiology, I will make sure the hot air oven is on. So if you are in any of those two lab, or maybe if Kempat has oven, I will put it on. Now, I'm going to put it on to enhance your drying, so you dry fast. Make sure you label your slide. Come with masking tape. Masking tape, very important. Come with masking tape. Come with something that you can use in lieu of plasticine, which can be bubble gum. Come with something you can use in lieu of plasticine, which is bubble gum. Come with something like that as well. So now, if the oven is on, you put your slide there, it dries fast, but still you're going to write that you air dried. The aim of doing that is just to aid you to be fast about the procedure. Now, if you use the oven, there is no need for you to go and start passing over flame 3 times, even though you're going to write it that you passed over flame 3 times, actually. But if you know you did not use the oven, please pass it over flame 3 times to heat fix. Make sure you do that so your smear does not wash off when you're staining. Now, I've taught you how to decolorize. So you stain with crystal violet for 60 seconds, Lugos iodine 30 seconds, decolorization briefly. I already taught you how to do that. And then you counter stain for 2 minutes. After which you drip dry and then you dab. Once it's dry, you apply the immersion oil. If you want to know how to view, please go and watch that video on gram staining. I'm saying it again. I said how you're supposed to view. When you close your iris diaphragm, rack your condenser up for a stain slide. So for a stain slide, you rack your condenser up, close your iris diaphragm. Open your iris diaphragm. It's a stain slide. So for a stain slide, you rack the condenser up, open the iris diaphragm so that as much light as possible should enter. Now, someone is asking, how long should it stay in the hot air oven? How long should it stay in the hot air oven? Basically, what I do, I told you that you should prepare all these things before you start writing. So you don't want them to steal your slide. So as you put it in the oven, stay close to your slide or be timing it. Between 5 to 10 minutes, your slide must have dried. For gram staining, no, it dries faster than any other smear. So 5 to 10 minutes in the oven is dried. So now, once it's dried, you go over and stain and do all of that. So for a stain slide, rack the condenser up, open the iris diaphragm. Now, you know that light coming through a straight line, once it hits glass, it diffracts. Light passing through a straight line, when it hits a glass, it diffracts. So to correct the refractive index of glass, once it hits to correct the refractive index of glass, that's why we have the immersion oil. So you already should know that unless the objective lens touches the oil, that's your immersion oil on your slide, viewing will not be possible. So you don't need to rack gently and put your eye in the eyepiece. Just rack up close to the lens. And then put your eye in and then continue racking gently. That's how to focus fast. That's how to focus fast, because the times 100 objective lens is called the immersion oil objective lens. So don't ever use times 40. I'll tell you, use times 40 to focus, times 10 to focus, times 40 to view. That one is in histo. Histo does not use immersion oil. What they use is DPX or Canada Balsam, which is a mountant and is covered with cover slip. As is immersion oil, and times 40 is called a dry lens. Oil should never touch it. Just like applying oil to your eyeglasses, it will spoil the lens. So what you do is to go straight to times 100. You're not focusing, you're not viewing anything. You're going directly to focus and view times 100. So that was how to do the gram staining. Now, you have done the procedure, you've gotten your result. Let's assume your result is gram positive cocci in clusters. At this point, you are going to implicate organism. So you write organisms implicated. Most students forget to write this thing and they lose the score for that. There is a score for organism implicated. Now, do not implicate organisms unless you have done gram staining. You only implicate organisms after your gram staining. So now, I want everyone to get a sheet of paper and pen. I will give you colonial feature now. You will tell me, I'll give you colonial feature and gram reaction. You will tell me the organism that you're going to implicate. Already, in the video on colonial morphology, I gave you several colonial features. Ma, please, when will you be free to personally teach me focusing? You can come from Monday. You can come from Monday. Because standardly in the exam setting, you should be able to focus in less than 30 seconds. In less than 30 seconds, that's the goal. Focus in less than 30 seconds. So now, I'm going to give you some colonial features and gram reaction. You will tell me organisms you're going to implicate. Now, it's just like they stole my phone earlier, and I was saying the guy that stole my phone is dark, is tall. Yes, before the exam. This coming Monday. Yes, sugar, yes. So if the guy is tall, is dark, is slim, there are several guys with that body formation now. So it is the same thing as implicating organisms. Do not implicate organism to species level. Only implicate to genus level. What do I mean? Never you say Staphylococcus aureus. Just say Staphylococcus species, Streptococcus species. Do not implicate to the species level. Just mention the genus and put SPP. So now I'm going to give you colonial features and gram reaction, and then you tell me what organisms you are suspecting. Right? Organisms implicated, you tell me. So now, right, the size. This particular organism now that we are trying to identify, the size is 0.5 mm in diameter. The shape is regular. The color is yellow uncleared. The consistency is butyrous. Elevation raised. The fermentation is lactose fermentation. Edge is entire. And then with a gram reaction, I did the gram staining. And after the gram staining, I got gram positive cocci in clusters. Please, class, can you implicate organisms for me? Quickly in the comment section. Quickly in the comment section. I hope you got the features I called. Please don't be lost. In my video on colonial morphology, I gave a list of colonial features for different organisms in the description box. So if you don't have it, please go back to that video, open the description box and check, and get it. It's already there for you. So please implicate organisms. Okay, Anastasia says Staphylococcus species. Now, don't implicate only one. Anastasia, implicate more. It's not only one. When police comes to a street to park criminal, they don't catch only one person. They'll park everybody and go to the station, and then you start bailing yourself. So don't implicate only one organism, because you're going to do biochemical tests now to know which one is the real criminal. So do not implicate only one organism, 2 and above. So give me another one. I'm waiting. Any other idea? Okay, Chisholm, Staphylococcus species, yes. Don't implicate just one. Give more. Okay, Emediong says Streptococcus species. Beautiful. Beautiful, beautiful, beautiful. So organisms implicated, Staphylococcus species. Streptococcus species. Please, house, can you kindly give me the biochemical test that will be performed? Now, what I mean, Anastasia, Chisom, Emediong, Sugar, please, everybody in the house, request for reagents. What will you request for? Just tell us in the comment section. Now, you want to differentiate staph from strep. Which reagent do you request for? Because now, at this point, you raise up your hand in the exam hall and say, Ma, and I will come to you. You say, I need this. So I say, I need this, and I'm going to bring it for you. It is not going to be there on your table. You will request, and I will go and bring it for you. You see why we don't write materials? It's as provided. And then it's also as requested. And when you request, we sign. But yes, you requested for this. Okay, Anastasia says she requests for hydrogen peroxide. Beautiful. Why are you requesting for hydrogen peroxide? What test do you want to perform? So you're requesting for hydrogen peroxide. You want to do catalase. So when you do catalase, I need you to know the principle. My phone is going off like, yes, thank you, catalase test. Catalase test. What other thing can you, aside catalase test, now what other tests will you perform? What else will you request for? Anastasia, it's catalase test, not catalyst. Catalase. Catalase, Catalase. So what other thing will you request for? Please, I need this class to be interactive. What other thing will you request for? You want to do coagulase. If you want to do coagulase, what would you request for? Some people know what to do, but they don't know, usually they don't know what to request for. You request for, what you are requesting for is plasma. Don't request for normal saline. Do you know why? Normal saline is already on your gram staining table. Your table for gram staining already has normal saline. So you already have normal saline. Don't request for normal saline. Only request for plasma. Plasma. Thank you. That's beautiful. So now, you know that the principle of catalase. Because now, after you must have implicated organism, the next thing to do You will say type 2 again, catalase test. Aim to differentiate Staphylococcus species from Streptococcus species. Then you go over to the principle. What's the principle? Sorry, the method. The method is the slide, the slide method, the tie. Yes, Vivian. After gram staining is catalase. That is if the organisms implicated is strep and Staphylococcus species and Staphylococcus species. We're talking about if the organism implicated is Staphylococcus species and Streptococcus species. Chisom said, I request for hygiene peroxide to differentiate Staphylococcus species from Streptococcus species to perform catalase tests. Beautiful. Yes. Yes. So you request for that if the organism implicated is Staphylococcus species and Streptococcus species. Yes. So now the principle is based on the ability of an organism containing the enzyme catalase to break down hydrogen peroxide to what? Water and what? And what? Oxygen, giving off as effervescence. Seen as what? Bubbles. Do you understand it? So that is it. All you have to do, get your clean grease-free slide, put a drop of hydrogen peroxide, and then you do what? You do what? You put the organism and emulsify. If the organism contains catalase, you will see bubble. The presence of effervescence seen as bubbles. So that's, you now say result, catalase positive. You will not write precaution. All this while, for gram staining, you're writing precaution. For catalase, no precaution. For coagulase, no precaution. It's when you are done. You give a central precaution, like about 4, between 2 to 4 precautions for all the tests. Yes, Chisom, you're correct. Yes. So you do coagulase. The aim of coagulase is to differentiate Staphylococcus aureus from other species of staph. Beautiful. And you know we have 2 methods. You have the slide method and the tube method. The slide method is uses the bound coagulase, while the tube method uses the free coagulase. So you give the principle of the bound coagulase. And the principle of the bound coagulase is the ability of an organism containing the enzyme coagulase. If the organism contains the enzyme coagulase, is going to cause the fibrinogen present in the plasma. It's going to turn it to fibrin clots. So you see it as a visible agglutination without requiring coagulase reacting factor. So that's what is going to happen. So it is the ability of an organism that contains the enzyme coagulase. The ability of an enzyme containing the ability of an organism containing the enzyme coagulase to convert fibrinogen present in the plasma to fibrin clots to cause visible agglutination without requiring the coagulase reacting factor. Do you understand me? And then you do to do coagulase, you put a drop of normal saline on both ends. You put it on both ends of your clean grease-free slide. You put it on both ends of your clean grease-free slide. Then you take the test organism, emulsify on one end. One of them is your control. You want to be able to differentiate agglutination from the organism that is just there. So you want to be able to differentiate agglutination from the normal bacterial suspension. So you use that other one as control. So to only one bacterial suspension, you apply your plasma, one drop of plasma. And then you mix and then you rock for 2 minutes. If you see visible agglutination, you say, okay, this is coagulase positive. Now, if you see visible agglutination, I'm promising you next week, I'm going to drop the video for catalase and coagulase. I already have them. I'm going to drop it for you. Now, if you see visible agglutination, what you have to do is to write, I put a lot of score to the organism confirmed, and nobody writes it. Out of 200, maybe only 2 persons will write it. I used to put like 4 marks there. So the question says, identify the organism labeled O as far as possible. Now, you did not identify as far as possible. You stopped at organism implicated. You forgot to write organism confirmed. You must write organism confirmed. Maybe you now say, okay, if it's catalase positive, you say Staphylococcus aureus confirmed. Then, only then have you answered the question. After that, you write precaution. You start giving all your precautions from gram. You write precautions for maybe 1 precaution from gram staining, 1 precaution from catalase, 1 precaution from coagulase. These principles we are writing on is for only the tests we are carrying out, right? For example, if I'm carrying out coagulase, the slide method, yes. If you are carrying out coagulase, the slide method, you should only write slide principle, the bound coagulase principle, yes. You shouldn't write both of them, only the one you are doing. Yes. So you give 1 principle, 1 precaution from gram staining, 1 precaution from catalase, and 1 precaution from coagulase. Only then have you answered the question. So that is it. So any question, we are going to wrap up this afternoon session here. We're going to begin the evening session by 5. So any question? Any question? Is there any question? Please, if you have a question, state it now. We're about to end this live session till evening. Is there any question? Please, if you have any question, please keep it till in the evening. I'll see you by 5. It's raining here. I'll see you by 5. Thank you.